Welcome to Module 5, Standards-Based Cabling Systems using TIA-EIA 568B Cabling Standard. Once again, I'm Ted Chandler, your CIS instructor for this online Network Cabling Systems course. In this module, you will learn to first identify the purpose and scope of the 568B standard. Next, you'll be able to name the structured cabling subsystems, including the entrance facility, the equipment room, the backbone cabling, the telecommunications room, the horizontal cabling, and the work area. You'll also be able to identify the horizontal cabling link versus the horizontal cabling channel. And finally, you'll be able to discuss copper and optical fiber cabling. In the mid-1980s, consumers, contractors, vendors, and manufacturers became concerned about the lack of specifications relating to telecommunications cabling. Before then, all communications cabling was proprietary and often suited to only a single-purpose use. In 1990, TIA and EIA published the first version of the commercial building telecommunications cabling standards, better known as TIA-EIA 568, or sometimes simply as 568. The TIA-EIA 568 standard was developed and evolved into its current form for several reasons. First, to establish a cabling specification that would support more than a single vendor application. Next, to provide direction in the design of telecommunications equipment and cabling products that are intended to serve the commercial organizations. Third, to establish a cabling system generic enough to support both voice and data. And finally, to establish technical and performance guidelines and provide guidelines for the planning and installation of structured cabling systems. The latest version is known as T568B, which was published in 2001. 568B standard generally addresses the following: subsystems of structured cabling, also called premises cabling, minimum requirements for telecommunications cabling, installation methods and practices, connector and pin assignments, the lifespan of a telecommunications cabling system, which should exceed about 10 years, media types and performance specifications for horizontal and backbone cabling, connecting hardware and performance specifications, recommended topologies and distances, and finally the definitions of cabling elements such as horizontal cabling, cross connects, telecommunication outlets, and so forth. 568B is published as a three-part document including B1, general requirements, B.2, which is copper balanced twisted pair cabling components, and B.3, optical fiber cable component standard. 568B specifies the recognition of cabling and connecting hardware, subsystems of structured cabling systems, that we should use star topologies in our design, cabling distances, installation practices, user interfaces, and link and channel performances. The 568B standard breaks structured cabling into 6 areas of subsystems. They are first the entrance facility, or EF, which is the demarcation point between the carrier, whether it's public or private, and the customers. The outside cables enter the building through the entrance facility. The next subsystem is the equipment room, which is the centralized space for telecommunication equipment such as PBXs or private branch exchanges, computers, video and audio switches that serve the entire building or campus. Backbone cabling is the distribution that provides interconnection between telecommunication rooms, equipment rooms, and entrance facilities. It consists of both intra-building, which means inside a building, and inter-building, which is between buildings, specifically on a campus. It also identifies the main cross-connect, or MCs, intermediate cross-connects, ICs, mechanical terminations, patch cords or jumpers, and horizontal cross-connects. The telecommunication room is the next subsystem, or also called the telecommunication closet, and this is where the horizontal distribution cables are terminated and cross-connected with the backbone cables. The fifth subsystem is the horizontal cabling, and this is the distribution of the physical media that connects each telecommunication outlet in the work area to the punch-down fields or the patch panels in the telecommunications room. And finally, of course, is the work area, and that's where the work is being done with telephones and computers, and this is where the telecommunication drops are located. And again, according to the standards, you need a minimum of one voice and one data jack outlet. It's important to note that many of the cabling subsystem functions can be combined into one area or space, especially in a small commercial building. For example, the entrance facility, equipment room, and telecommunication room can all be combined into one room. Also note that the 568 standard applied to both multiple buildings or campuses as well as a single multi-floored commercial building. And then note that standards cover voice as well as data. This slide shows an example of an entrance facility. The entrance facility, or sometimes called the DMARC, MDF or main distribution frame, POP or point of presence, and finally sometimes it's called the MPOE or main point of entry, as defined by the standard 568, specifies the point in the building where the cabling interfaces with the outside world. All external cabling, campus backbone, interbuilding, antenna pathways, and telecommunications providers like the telephone company and Cox Cable should enter the building and terminate in a single point or space. Past this point, the customer provides all the equipment and cabling. Maintenance and operation of equipment past the DMARC is also the customer's responsibility. The entrance facility may share spaces with the equipment room if necessary or possible. Some entrance facilities also house telephone or PBX equipment. To improve data and voice security, the entrance facility should be located in an area that can be physically secured, such as a locked room. This slide shows the equipment room and its next subsystems defined by TIA 568. Equipment rooms are centralized spaces for building servers or campus serving telecommunications equipment such as PBXs, computers, routers, switches, video and audio switches that serve the entire building or campus. The equipment room is a centralized space specified to house more sophisticated equipment than the entrance facility or the telecommunication room. Backbone cabling is specified to terminate in the equipment room. In smaller organizations, it is desirable to have the equipment room located in the same area as the computer room, which houses network servers and possibly phone equipment. Telecommunication rooms are where the horizontal distribution cables are terminated and cross-connected with the backbone cables. This is done using patch cords connected between patch panels located on 19-inch racks. The third subsystem of structured cabling is called backbone cabling. Backbone cabling is sometimes called vertical cabling, cross-connect cabling, riser cabling, or inter-room cabling, intercloset cabling. Backbone cabling is necessary to connect or tie the entrance facilities, equipment rooms, and telecommunication rooms together. Backbone cabling includes cabling between equipment rooms and building entrance facilities, In a campus environment, cabling between buildings, entrance facilities, and vertical connections between floors. Horizontal cabling also includes cross-connects, which are patch cords or hookup wire within the cabling system that permits the termination of cabling elements and reconnection of those elements. Examples of cross-connects include main cross-connects, intermediate cross-connects, or horizontal cross-connects. Note the star topology that is used in the backbone cabling. Maximum backbone cabling distances and approved media include, for UTP data, it's 90 meters or 295 feet. UTP voice applications, it's 800 meters or 2,624 feet. Screen twisted pair is also 90 meters. Multi-mode fiber is 2,000 meters. Single mode fiber is 3,000 meters. This slide illustrates the relationship of a telecommunication room to the horizontal cabling and work area. The telecommunication room or closet is the location within a building where cabling components such as horizontal cross-connects and patch panels are located. The standards call for at least one telecom room per floor and 3/4-inch plywood painted with anti-flame retardant white paint and mounted on 2 of the 4 walls. These rooms are where the horizontal structured cabling originates and backbone cabling terminates. Horizontal cabling is terminated in patch panels or punch-down termination blocks and then uses horizontal pathways to reach the work areas. The standard allows for one transition point in horizontal cabling. A transition point is where one type of cable connects to another, such as a multi-user telecommunication outlet assembly or MUTOA. A transition point can also be a point where cabling is distributed out to modular furniture. Note that a star topology is required for horizontal cabling subsystems. The 5th submodule or subsystem is the horizontal cabling that runs from the telecommunication room to the work area outlet. The horizontal cabling runs are usually implemented with 100 ohm, 4-pair, unshielded twisted pair, solid conductor cables as specified by 568 standard for commercial buildings. The standard also provides for horizontal cabling to be implemented using 150 ohm shielded twisted pair cable, 62.5 125 micron optical fiber, and 50 125 micron multimode optical fiber. It's very important to understand the differences between a horizontal cabling basic link and a horizontal cabling channel, especially regarding the distance limits and for purposes of certification testing. The basic link contains only the cable found in the walls, the horizontal cabling, one transition point, the telecommunications outlet, and one cross-connect or patch panel. It is assumed to be the permanent position of the cabling infrastructure, or the permanent portion of the cabling infrastructure. The basic link is illustrated here in this slide. The channel link includes the basic link as well as installed equipment, patch cords, and cross-connect jumper cables. However, the channel does not include phones, PBX equipment, hubs, or network interface cards. 2 possible channel link configurations are shown here. One is the channel link for a 10-base-T Ethernet workstation and one for a telephone. The maximum distance for a horizontal link is 90 meters or 295 feet and 100 meters or 328 feet for a channel. To review the requirements per the standards, the maximum horizontal cable distances are 90 meters or 295 feet for the link and 100 meters or 328 feet for the channel. And the approved horizontal cabling media include 4-pair 100 ohm 24 AWG or American Wire Guide solid conductor UTP cable, 2-pair 150 ohm STP cable, and 2-fiber either 62.5 125 micron or 50 125 micron optical fiber. Modular patch panels or patch cords are used to provide the connection between field-terminated horizontal cables and network conductivity devices such as switches and hubs. Because of their role in structured cabling infrastructure, modular patch cords are always the weakest link. Whereas horizontal cables contain solid conductors, patch cords are made with stranded conductors because they are more flexible. The flexibility allows them to withstand the abuse of frequent flexing and reconnecting. Although you could build your own field-terminated patch cords, I strongly recommend against it. The standards specify that each work area shall have a minimum of 2 information outlet ports. Typically, one is used for data and one for voice. The outlets are identified by a number of names including drops, information outlets, wall jacks, and wall plates. The telecommunication outlets are considered to be part of the horizontal cabling subsystem. Network adapters, balance, filters are outside the scope of the standards definition of work areas. The TIA 568B1 specifies performance requirements for unshielded twisted pair cabling, shielded twisted pair, and fiber optic cabling. Further, specifications are laid out for length of cable and conductor types for horizontal cabling in the backbone and patch cords. The standard specifies 3 categories of UTP cable to be used with structured cabling systems. These are commonly referred to by the category numbers and are rated based on the maximum frequency bandwidth and include Category 3 for voice-only applications up to 16 megahertz bandwidth, Category 5E 100 megahertz bandwidth, and these are used for 10-base-T Ethernet and residential, and they can be used for voice, video, and data applications, and of course Category 6 that has an upward bandwidth threshold of 250 megahertz, and these are usually used, Category 6 is usually used for gigabit Ethernet with data, voice, and video applications. The TIA 568 standard permits both single-mode and multi-mode fiber cables. Horizontal cabling systems are specified to use either 62.5 or 50 micron 125 multi-mode cables, whereas backbone cabling may use either multi-mode or single-mode optical fiber cable. Fiber optic cable is referred to as either single-mode or multi-mode. The term mode refers to the bundles of light or of rays that enter the fiber optic core in the fiber strand. Single-mode fiber optic cable uses only a single mode of light to propagate through the fiber cables, whereas multi-mode fiber allows multiple modes of light to propagate. In multi-mode fiber optic cable, the light bounces off the core walls formed by the cladding as it travels through the fiber, which causes the signal to weaken more quickly. The information outlets wired for UTP should follow one of 2 conventions for wire pin assignments or wiring patterns. These are T568A or T568B. They are nearly identical except that pairs 2 and 3 are interchanged. Neither of the two is the correct choice as long as the same connection is always used throughout the cabling system. T568B is much more common in commercial installations, but T568A is now recommended for configurations. T568A is the required configuration for residential installations in accordance with 570A. The T568A configuration is partially compatible with an older wiring scheme called USOC, which is commonly used for voice systems. Be consistent at both ends of the horizontal cable. When you purchase patch panels and jacks, you may be required to specify which pattern you are using, as the equipment may be color-coded to make installation of the wire pairs easier. However, many manufacturers now include options that allow either configuration to be punched down or connected on patch panels using jacks. Once you know the two color codes, you can build either a straight-through or crossover patch cord or equipment cord. Note that when you build a patch cord, you use either T568A or T568B for both ends, whereas when building a cross-connect cable, you use T568A on one end and T568B on the other. Note that with a crossover cable, rather than like a straight-through cable with the wires going from pin 1 to pin 2, pin 1 to pin 1, pin 2 to pin 2, and so on, the wires go from pin 1 to pin 3, pin 2 to pin 6, pin 3 to pin 1, and pin 6 to pin 2. Also regarding cable design, please recall from Module 1 that the following are the maximum cabling lengths depending on whether in the entrance facility, equipment room, telecommunication rooms, or the work area. The distance limits mandated by the standards are, when you're using copper in the backbone, it's limited to 90 meters for data applications and 800 meters for voice applications. As far as the optical fiber in the backbone is concerned, you're limited to 2,000 meters for multi-mode fiber and 3,000 meters for single-mode fiber. Also, in the horizontal cabling system, the link length is 90 meters and the channel limit is 100 meters. That's whether you're using copper or fiber. So in this module, we identified the purpose and scope of 568B standard, named the structured cabling subsystems, including the entrance facility, equipment room, backbone cabling, telecommunication room, horizontal cabling, and work area. We also identified the function of each one of those subsystems. We identified the horizontal cabling link versus the horizontal cabling channel, and we discussed unshielded twisted pair copper and the various types of optical fiber cabling used in network cabling systems. This completes Module 5. Please take the exam, and I'll see you in Module 6.